SAP COOIS Automation Series. Part 9, Building the Automated Response Engine. In the previous parts of this series, we designed an exception intelligence framework for SAP COOIS data. Step by step, we built a system that can detect deviations in production orders. We started with automated data extraction. Then we added validation rules. After that we introduced classification logic to separate data issues, operational problems, documentation gaps, and system configuration errors. Next we ranked severity. Then we built a scoring model to measure business impact. And finally we assigned ownership so every exception had a responsible function. At that stage, our system was very good at answering one question. What is wrong? But a professional operational system must answer the next question. What happens next? That is exactly what Part 9 introduces. Today we are building the automated response engine. This is the layer that converts exception intelligence into operational action. Section break visual, architecture diagram. Let's start with a simple idea. Not every exception deserves the same level of attention. Some issues are minor. Some require monitoring. Some require immediate action. And some represent serious operational risk. If a system treats all exceptions equally, teams quickly become overwhelmed. This is where response tiering becomes essential. Section, Response tier concept. In Part 9 we introduce the concept of response tiers. A response tier determines the urgency of response required for each exception. Our framework defines 5 levels. Tier 0 means the record is clean. No action is required. Tier 1 represents minor issues that should be monitored. Tier 2 indicates that action is required by the responsible owner. Tier 3 represents an operational escalation. These are high-risk issues that require immediate attention. And finally, Tier 4 represents critical integrity risks. These issues may require management intervention or system investigation. This structured approach ensures that escalation is controlled and meaningful. Now let's look at how the system determines the response tier. The decision is based on 4 inputs: classification, severity, impact score, and final confirmation status. If the classification is clean, the system assigns Tier 0. If the severity is low, the system assigns Tier 1. If the severity is medium and the impact score crosses the defined threshold, the system assigns Tier 2. If the severity is high and the operation has already reached final confirmation, the system escalates to Tier 3. And if the severity is high and the classification indicates a system integrity issue, the system assigns Tier 4. This ensures that escalation reflects both operational context and business impact. But identifying escalation levels is not enough. A professional system must also record escalation events. This is why we introduce the escalation log. The escalation log acts as the historical memory of the system. Every critical exception is recorded here. Each record captures the timestamp, the exception key, the production order, the work center, the classification, severity, score, owner, response tier, and status. The initial status is set to open. This log allows teams to review past escalations and track unresolved issues. It also creates accountability. Every critical issue leaves a trace. However, there is an important challenge. SAP COOIS exports change frequently. When the data refreshes, rows may move, operations may reorder, and the dataset may look slightly different. If our system relied only on row numbers, the same exception could be logged multiple times. To solve this problem, we introduce a stable exception key. The exception key uniquely identifies each operational exception. In our implementation, the key combines three attributes: the production order, the work center, and the classification type. For example, order 1000324, work center pack 01, classification business, yield variance. The exception key becomes 1000324 pack 01 business, yield variance. This key remains stable even if the sheet refreshes or the row position changes. Before logging an escalation, the system checks whether the exception key already exists in the escalation log. If it exists, the system ignores it. If it does not exist, the system writes a new escalation record. This prevents duplicate escalations. But we also optimized performance. Instead of searching the worksheet repeatedly, the system loads existing exception keys into memory using a dictionary object. This allows the system to check thousands of records instantly. Even large datasets remain fast and responsive. We also introduced an escalation control block. This consists of 3 additional columns in the main dataset. The escalation flag indicates whether the issue has already been escalated. The escalation timestamp records exactly when the escalation occurred. And the resolution status tracks whether the issue is still open or has been closed. These fields allow teams to manage issues systematically rather than relying on memory. At this point, the system performs a complete operational cycle. It detects deviations, classifies them, measures severity and impact, assigns responsibility, determines escalation levels, and records escalation events for governance and accountability. What began as a simple SAP report has now evolved into an exception intelligence engine. Instead of manually scanning hundreds of orders, the system highlights only the issues that truly matter. This is the real power of intelligent exception management. We do not try to monitor everything. We design the system to identify meaningful signals within operational noise. In the next part of the series, we will extend this framework even further. Part 10 will introduce risk trend monitoring. We will begin analyzing how exception patterns evolve over time, identifying high-risk work centers and tracking resolution performance. That is where operational intelligence becomes predictive rather than reactive. And that is where this framework becomes truly powerful. Thank you for watching.